Okay, so here's problem number 4 out of the 3.1 homework. So we're going to find the equation of the tangent line, only we're going to use the alternate definition of the derivative. This is the other version that can happen, and you'll see it. And what you, as you probably have heard, you know, there's easier ways to do this, and there certainly are, but this is just another way to where it all comes from. So, you know what I'm going to do is I'm not going to use 5. I'm going to use A, because what I'm trying to do is build a formula for this, because that's part of the derivative. You know, the slope is the slope at a point, and the derivative is a formula that gives us the slope of a curve. And so let's have a formula. So the formula I'm going to use is f of x minus f of a over x minus a. And now the trick is I gotta simplify it. So, and then when we're done, when we have a formula, I'll find out the slope. So I've got this function. I know f of x equals negative 5 minus 3x squared. So that's f of x, and I know that f of a is negative 5 minus 3 times a squared, right? Now just replacing the x with the a. Now let's plug this. Here's my pointer. So this is y1, this is y2, the way I've got this set up, right? Over x over y, well, I guess whatever, I got 2 minus 1, x2 minus x1. So I've got negative 5 minus 3x squared minus, notice those parentheses, negative 3a squared all over x minus a. And of course I'm taking the limit as x approaches a. That's the initial setup. So now I got to do some cleaning up. Because if I substitute an a now, I get 0 over 0. So I need to remove that discontinuity, right? It's a removable discontinuity. So, whoops, let me get a pen going here. Negative 5 minus 3x squared. And then you distribute that negative through. So that gives me plus 5 plus 3a squared all over x minus a. And of course that 5 and that 5 cancels out. And then I see a negative 3x. So here, I see a negative 3x squared and a positive 3a squared, and there's nothing else in the numerator, and I think I can factor out a negative 3. So if you don't mind me making this jump, I'm going to factor out a negative 3. That makes it x squared minus 1 a squared, or x squared minus a squared all over x minus a. And I should be writing the limit, but while I'm doing the simplification, I'm not going to. So I'm going to move this up here so I give myself some real estate. And I'll change it back to black. So then x squared minus 1a squared, that's the difference of two squares factoring, right? So negative 3 times x plus a times x minus a all over x minus a. And then, as you can see, this is why I factored out the negative 3, because that cancels. So, and that's where the discontinuity gets removed. So then, I'm going to take the limit as x approaches a of negative 3x minus 3a. Well, as I distribute, now I'm going to take the limit, plug in a, so negative 3a minus 3a more is negative 6. Negative 6a is what the derivative is. So I know that f prime of x, or f prime of a, really, because I don't have any more x's, do I? Let's see, eraser. F prime of a equals negative 6a. And now the point I'm supposed to find the slope at, or write the equation at, is here. Let me move this up. Move that up, move this up, let's move that up. Here we go. I want to find the slope at the point on this curve of 5, let's see, it's 5 negative 80 is what math lab gave me, my lab gave me. So what's f of 5? Well, I think that's going to be negative 6 times 5, which is negative 30. And then I have an x and a y already, so this is x1, y1. So if I use point slope form, as Patrick JMT did, I'm a fan of point slope form. It makes life so much easier. So y minus negative 80 turns to y plus 80 equals negative 30 times x minus 5. And that's my equation of the tangent line. MATLAB likes to have it, or my lab likes to have it solved for y, so you could just do this, then minus 80, bring the 80 over, and you type that in, it will give it to you. You don't not have to write it in slope-intercept form. Sometimes it might make you, but that's just it. Okay, so that is the second definition of the derivative. It's almost easier than the h. Sometimes how to collect the terms and cancel out is a little harder, but that's what you can do. You can also do this problem with the other definition if you like that better. Okay.